Let's see. Okay. Let me do one quick little check here. I got to make sure that my mic is on the right mic, which isn't always. Okay, I should be good. Good, good, good. Okay. Yeah, so I've got my metric template up. So let's jump into this thing. Let's look at some sizing here. Uh, overall, might be a little bit tricky to figure out here just because I'm not given it explicitly. I'm given portions of it, and so to come up with kind of a width and a height here, I think the height's a little bit vague. I don't have an explicit height. 95, but it's on an angle to the base. So I'm definitely using this as front though, and then down, top down, and then foregoing a right side view. So yeah. So let's see. Um, yeah, overall, I definitely have like 95, and then this is 120 degrees, depending on where you're looking, 60 one way, 120 the other. So 95 and 40. So I might do a little calculation here with my calculator. It's across the width of this, 95 plus 40 at least is what I'm seeing. 135, that would just be from point to point out here. And then it's going to slope up 95 millimeters from there. So I might be able to kind of pencil that in a little bit. Yeah. Then I'll figure out that'll help me figure out what the overall height is. So this one I might kind of piece together the box that it'll fit in. And then the overall depth in the top view is going to be 90 plus the 25 radiuses that I see. So 90 plus 50, maybe 140 across the top for the depth. Okay. So I'll have that up on my other screen. Let's do this. Let's see. Do some construction work. I might piece this box together rather than draw a rectangle for myself, but you can draw this however you want. Because the one thing I do know is this dimension, 135, is at least how far it is. And the height, I don't know. It's going to go up some height here. So I think I'm going to come over here. I might make sure that I'm going to be able to draw at 30s and 60s or 120s because I have that angular measurement in my given information that it will be 120 degrees like this. Up some height here. This is pretty easy in CAD to draw because I can actually add that height while I'm polar aligning to that. 120 degrees. So I could tab over and make it lock in at 120 and then tab back. Because you could pull that slightly, right? So if I lock that in at 120, it's a little safer. And then 95 is how long this side of that is. So it ends up looking something like about that. Yeah, 135. That's my 95 plus 40. Yeah. Hmm. And then this is the one that's going to come over here. My part, I don't think, yeah. Yeah. Yes, you can. Let me get off there.
The baseline and then the 95, that's a 123 equal, you can join them. And then you can offset them. And it makes a perfect shape.
Yeah, let me see here.
But you are still making the box, but.
Yeah, but yeah, if I stop there, I think I can get Sky to get logged in. Yes. Right, right. Yeah. And so I'm going to finish my box. You probably don't have to here. But this is technically the boundary of that, right? But yeah, I see what you mean. Yeah, whatever absolutely. The way I see geometry does not have to be the way you see geometry. Roll with it, as long as your dimensions are right. Maybe check them before you actually start dimensioning them. Just that, yeah. But heck yes, there's so many different ways to get your shapes in. Yeah. So that's definitely going to be the overall height of this based off that 95. So it ends up being 82.27 millimeters high there. So that makes sense. That's 95 on a slope, so it's not necessarily going to measure 95 height wise. That's good. And then oh yeah, and then I never checked what the overall dimension ended up being here, but it's also one that I wasn't explicitly given. 182.5 millimeters. So that's not bad. So maybe I'll just project this up. I'll just build a projection plane up here. So like this is no specific height here. I'm 197 millimeters above this, but I'm just gonna give myself a little bit of space. Um,
Okay, you're good.
okay. Maybe I'm going up here 100 and plus something to start my top view. Yeah. But yes, then I can offset this and figure that out here now. Yeah. I like that. Let me jump back in and I'll show you my screen again. Here I come. Excellent. Overall depth, I think I decided was 90 plus, yeah, for the overall depth would be a 90 plus 50, 25 this way, 25 this way. And then I've got some more to figure out that way, but for sure I'll get the overall here. So I call that 140. So I could offset this 140 maybe. 140 millimeters, offset this thing. That's the overall, and then maybe I'll extend these. Extend, they should end up being able to extend. If they don't extend like that, it's just not pull, they're not in orthographic alignment. So there's my boundary of what the top view will take up. And then, yeah, if I look back on the assignment cheat sheet here just a little bit, I'll go into this and see kind of the way I'm heading. I do think I ended up having to take 3 viewports of this when I placed mine in here, so I'm not going to worry too much that I have enough room to get it all in one viewport. I'm just going to continue to proceed and know that I just add more viewports, so I'm not going to worry about it. I'm going to project this out when I do it. So I do need a little bit of room. So I mean, I'm kind of thinking of at least giving myself a little room. I'm going to be projecting over this way for this view. Yeah, I mean, I could take the top view up higher, and I might find that I do, or I might have to project that way out further to get into a clean area to detail it, but that'll be fine. I'll be able to take my viewport from over there as well. So, uh, yeah.
You said the width was one.
Yeah, this one here, the depth 140. Yep, that's 90 plus yeah, that's the outermost. It's really only that dimension way up there on the little sloped plate with the holes in it. But yeah, it's that linear length plus the 2 radiuses, 25 and 25. So 90 plus 50, 140. Yeah. And I think I'll start drawing the front view here. So now that I've got that, draw some visible line work here, I think. Maybe I'll just start over here. This is 20 millimeters. I haven't drawn, and then this one goes across. Maybe I'll just pull it across here. I got to trim that. It's 20 millimeters through, and then I hit this. This is also 20 millimeters, so I could offset this one. And maybe that's what you were telling me. So it's 20 millimeters through thickness here as well, like that. So I think I'll make this one a constructor of like this. That kind of shows where those two will intersect right there. I can trim those off. Something like that. I don't know if that looks totally right, but I think that's, yeah, I think I'll probably end up like dropping this down perpendicular to that. But that could be wrong. I might have to actually take that back. I'm going to undo that one last trim. Maybe not. I don't know. Let me look at this. Come back to that. But for sure, this does come over this. I'm going to retrace over this. And then this should stay 95. And then, yeah, my boundary box is a little bit misleading because you might think it has to stay in there, but it doesn't. So I'm going to draw this one perpendicular now. I'll just leave it long. It's actually perpendicular. I should say 90-degree corner here, right across the top here. So that's 30 degrees is also what I'm seeing show up. I'm just clicking it long here. I'll trim it off, but that's technically how what the boundary of this is, and that's based off of this. I'm keeping this at 95 millimeter for sure. So it's breaking the boundary to like this, which it should. Like I could probably move this now. Technically, this was the inaccurate um, boundary, but I think I'm going to snap this to there. Technically, that's the overall height here. Once I consider like the thickness of the which I think of like a thickness here, how thick this is. It kind of impacted my boundary a little bit there. So wasn't so yeah, I just be aware of that. I initially locked it in off the 95 millimeter dimension, but that wasn't quite exactly right. So my boundary for height is 92.27. As an overall dimension, that's kind of a worthless dimension, but it is nice to have on a print still that I know kind of an envelope. It's like a part envelope that I think of. And so I like to include those dimensions. However, they're not always the most useful dimensions. They're kind of more informational, even referenced. I mean, they can be considered reference because it's just a weird dimension. It goes to this top edge, right? So it's not to a great surface that I would pull that dimension to, but it's good for information. Anyway, let's continue on and see what else I need to do here. So um, I think I'll put in the other pieces here. In order to locate that, I'm thinking of it just based off this radius of 40. So I'll come back in and trace over this line to where I can at least put in the concentric nature of these are going to be so these are axial aligned, right? I've got kind of an inner bore and an outer bore this of the cylindrical feature of this. And then it's going to be concentric to the big outer radius there. So I think I'm going to base everything off that 40 millimeter radius and put that in my front view and then worry about some of these diameters, a 65 and a 35 diameter. So let me do that. And it's 25 millimeters above that surface that's 20. So 45 overall here, 20 plus 25. Okay, so I'll have that up to detail that. Detail those cylindrical features in their rectangular view here. So I feel like what I want to know is maybe I just need to know where the center of that is. So I might just cursor over from here like 40 millimeters. That's the axial center line that they all share. So maybe I'll just pull that up through my boundary here. So all of those are based off. This is essentially a center line. And this is all radius, this is a foreshortened radius surface that I'm looking at here and a nice flat surface that I'm looking at here this is the point of transition. So yeah. So I think I'll just draw those in as visible from that based off that center line, right? So, goes over here. Maybe I'm just going to cursor over so I don't do a bunch of visible line over the top of visible lines, but 32 and a half, 65 divided by 2. So I'm wanting to turn that diameter into a radius in my head. So I say 65 divided by 2 is 32 and a half, 32.5. That's the radius of the OD of that cylinder, and it's 25 millimeters tall. And then it's going to go over this way, 65 millimeter, and then back down to here, right? That's what that one looks like based off its center line. And then it has an inner bore that will be hidden, and I can put that in here while I'm here. Maybe I'll just put it in as hidden line work just while I'm thinking about it. It's going to look like what 35 and a half is 15 plus 2 is 17 and a half. Half of 35, 17 and a half. Pull out your calculator if you need it though. I say 17 and a half. And this will be the through bore here. So I might repeat that over here. I could mirror that, but I can just probably enter in 17 and a half. So that's that inner bore. Do yourself a There's your calculator, by the way. If you ever need your calculator, it's in your measurement area, your utility palette. I'm just measuring. I'm just doing myself a little double check before I project a bunch of stuff. Definitely check yourself. That's 35. That's great. Sorry, I should have done one more check of the diameter here. 65. Yeah, I'm happy with that. That should project correctly. And then I just have this gusset. I kind of consider this feature a gusset. Um, and maybe this is a 3D printed part, all uniform. Maybe this is actually three different pieces. If something was built out of metal, this particular piece could have been cut out totally flat and then bent. So we have press brakes that will bend metal up to certain thicknesses. We can bend really thick metal, but it does cause a huge like radiuses on the external and internal places where it bends, where that material stretches and forms. So thicker material has much more stretching, much more like material usage into the radius of inner and outer corners when parts are really thick. So 20, sorry, this is sometimes my head goes this way, but 20 millimeters is um, I don't know, divided by 0.03937. Sorry, let me go the other way. 20 millimeters times 0.03937. All I'm doing is converting this. This like 20 millimeters is actually over 3/4 of an inch thick. That's really thick. I mean, if you're talking steel that's that thick, you're talking about it will hold up, it'll hold up. It's bridges and skyscrapers we're talking about here. So this is very thick material. And so it would have, like when you bend really thick material, it doesn't bend at a nice sharp corner like is shown in this picture. It will actually be like a big radius to it, and it would stretch the material strangely, and all equipment can kind of be different when how it stretches material. And so usually it takes people that are going to do that, they have to know their equipment and they have to like match the dies and the punches to the material thicknesses. And then the person like you or I or the engineer, we have to actually give them the right material, like it's going to stretch and pull. And so sometimes we have to add extra material to actually hit the dimensions we need. We have to like sometimes subtract and sometimes add materials when parts are getting bent. It's a and you're reading about that a little bit in chapter 4 of theory, like the manufacturing concepts of bending and forming metal and plastics in that case too. They stretch differently than metal, but kind of and some anyway. So I don't know. I like to think through these processes of how this was made. This is potentially like three different parts. If this was made out of metal, this would be what I'm saying is this would be a very hard bend to kind of get and pull off and have the accurate measurements fall. It would take some experience to figure out what my equipment does, if that's what I got to do. Or maybe I'm going to cut that and actually miter cut this like you would if you were working with wood and saw cut those bevels and then have a welder maybe join them. And that's a total way that this could be done. And when you work for places, you just kind of learn what their manufacturing practices are, and it's usually based off what equipment they have access to. The equipment to do all this kind of work, to form, stretch, mill, machine, is very expensive. So, uh, you know, companies try to purchase stuff that's a well-rounded equipment that they can do a lot of different things with. Sometimes they have to kind of know their rules before they break the rules on what they can and can't do, and it might affect how parts are made. So you can't just be like, well, all you need is a fifth axis laser cutter. This would be easy. It's like, well, yeah, that's like several $1 million. Maybe this company's not going to invest in that, and you're going to have to kind of do an old school way of doing stuff. So you just have to be aware of like what equipment, and you won't know that until conversations happen. Yeah, so that's good to know. So I don't know how this is being made, and it doesn't even show any welds, and it doesn't have any weld callouts. I don't even know what material it is. So we're all in this vague land, but I like to think through what if this did need to be made. It does impact how I would draw things sometimes, but in this case, we just kind of proceed like it can be made no matter what. It doesn't matter. So it really does matter though. But what I have is kind of a cylindrical feature. Maybe this is a piece of pipe cut placed on this plate that's been bent with holes in it. Maybe this was cut out when it was flat and then bent to be in this kind of L-shaped. And then I have this little gusset support here. And when you see something like this happening, generally it's like a rigidizing feature. Like it's trying to, this part might be experiencing some kind of a load between whatever these holes are mounting to and whatever's going through here. Like they're just worried about the bent nature of this. Maybe it can't hold up to the load, and so they put what's called a gusset in here to additionally support. And it looks like they run this gusset clear over to the cylindrical features. Is almost like they're almost like just they're taking forces that might exist and be exerted on this like inner bend and fatigue it potentially. And when they apply this gusset in here, you can kind of push some of that force over to the cylinder and kind of balance out something that might break under some loads, and now it won't. And so this is a gusset, and this is kind of how it's used a lot in manufacturing practices as a kind of a strengthening feature. Even if it was a 3D printed part, it would strengthen that part substantially to have that gusseted uh, uh, in case what it just depends on the loads this is seeing. So it's definitely an engineered design. And it might be based off of previous failures. So that's the other thing as a draft, you don't decide that design looks stupid. I think it looks bad. I'm going to change it. And you'll be like, well, actually, we learned that that needed to be that way over repeated failures. And this has been bolstered now. So anyway, but I'm going to draw this in. It looks like it just goes from point to point, like goes from the cylindrical feature up to the very top of my plate. And so I should be able to just draw that in on my drawing here. It just goes from point to point here. So I'd have this visible line that is the side view of this front view of this gusset that goes like this. And just by the other shape, that's the shape of the gusset, you know. So the other thing I have is maybe I'll focus on the internal holes that are up here. So I've definitely got some. This is not just one surface. It actually is a flat surface, and it's radius and comes back towards me, and then it radiuses away from me to the top. So I think I'm just going to put in the holes. I won't really see all that. That goes into that case where do we show the extents of the radius or not? I'm not going to worry about it here. I'm just going to have to understand that this has got a lot going on in this particular surface in my view. Let's put in the holes that go through it, kind of like I did here, just because I did them over there. So let's see. They just come down. They are concentric holes to this radius. So I've got a 25 diameter hole through a radius that's 25. And they're concentric. And so how far down are they? Well, let's see. I do have a linear dimension there. They're definitely 90. That's going to help me in the top view. They're just on center. So they'd be 25 millimeters down using the radius. So this is a 50, this is a 50 diameter across. So I'll just come down 25 and then base my whole uh, pattern off that. So, and maybe I'll just put in a construction line for the center of this as well. So what I'm saying is this comes down from here, 25, and maybe I'll just trace over this with construction line work. Sometimes you can't like cursor over, maybe if it's out of alignment here like this, it won't really let me. So maybe I'll snap this construction line down 25. And through here is kind of a center line is what I'm thinking this of. And then I can just offset this piece maybe. The whole diameter was 25 diameter, so it's a 12 and a half radius. So I feel like I'm going to offset this 12 and a half. That's half of 25. And that's how I'm going to say this is offset this way. And your offset command is a continuous command. It'll let you keep offsetting whatever. But I think I'll just match these properties of this hidden line work over here. That's my whole through there. And let's start projecting stuff up. So I'm going to do some of these features need to project up. This edge needs to come all the way across. Looks like I need to trim that too before I get too carried away. This is trimmable material here. There it's gone. So I'll project a lot of these features, these points to points. So I've already got those 2 points. I'll come back to the hole in a second. Maybe I'll worry about the visible line features first up here. So I'm going to project this one up too. I've got center line work to worry about there, but this might be enough here. I think I want to know this point though, right here, where it turns and at this point here, it's where that what I call a break line or a bend line is has that material is now from here up. This is a foreshortened surface in my view. Okay, so and I think I'm going to put in one more. I'm going to put in a center line. I think I'm going to base a lot of this off a center line here. I don't really have a center line here, I don't think, because I've extended that line. So I might just cursor over and put a center line in here. So this thing is what I say, 150. So half of 150 is what 75? That sounds right. So I'm gonna cursor up here 75 millimeters. This is the center line of the top view. Does that even look right? Yeah, but I think I'm wrong. 75 sounds right to me. It's funny that that doesn't, so I got it just visually, mine looks like it doesn't, I don't have this drawn correctly. So I'm gonna measure this. That's 75. What did I do here? Measure distance. 65. Who the heck drew this top view? I did. I don't know where I went wrong, but I could see it. I could see that I don't have the same. Somehow I only put 140 in. It would be 150. So this one is wrong. I'm going to delete it. I'm going to re-offset this. 150. I think I just was thinking wrong. And if I told somebody else wrong, sorry. That should be 150 overall there, which I think I said. I don't know why I typed in 140, but and then I'll just extend all these. So this is my way of fixing this. Extend, 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 extend. Excellent. Now I've got a 150. If that was only a few millimeters off, what's that? Oh, it's 90 plus 50 is 140. Oh yeah, yeah, yeah. So I don't know where I'm coming up with 150. Back this truck up. Thanks, Riley. You could have stopped me before I did all that work. This is what I you should doubt. You should question with boldness everything I say. Yeah, I actually want to offset this half of 140, which would be 20 plus 50, right? Yes. 70. That sounds better. My problem was the way I offset this one. I just wanted a center line there. Yes, good, good, good. 150. Don't do what I do. Yes, do it right. Don't do it as I say it. I'll get there eventually. Trust me, I'll get there. Maybe. I think I'm going to project this one up. Yeah, that's good. I projected that center line because I think I'm going to start this thing with my center line. Yeah. Yeah, you guys definitely can draw way faster than me. Do I have this right? Yeah. I got to do some checking here. What am I doing? This should be 40, and it is 40. Okay, okay. So this should be. Oh yeah, that makes sense. Sorry, I'm thinking that it should be the overall width, but it's not. It's only 80 through this area. The reason why I'm this wide is just because of the top plate. Yes, yes. It's coming on. It's coming back to me now. Sorry, I haven't drawn it for a while, and you guys have never drawn it, so yeah, this is 40. It's my outside edge here. This plate's going to come back from the quadrant back to. I'm gonna pull it through here and trim it to fit maybe. I'm just gonna pull it through. It really only pulls through to the bend and then it comes up a little bit more and then it's got some fillets going on. And so good. And then I'm going to come and repeat that over this way. Yeah. It's going to look something like that at first, I think. And it's got my other diameter holes, which I've already pulled. So I can just go ahead and pull those two holes here. I've got this diameter is the outer 65, 32 and a half. That looks correct. And then this other one, I don't really have I haven't projected up, but I can. I could also just, I could also just, not totally necessary to do this. You could have just drawn it in and put in the number, but this hole would be like this. That seems correct. And this gusset comes up to this. So this bend line I'm going to pick up as a visible line for sure. So this is going to be, I'm going to see that change in from plane that's flat to an inclined plane that's coming up at me. I've got some trim work to do once the gusset's in, and so I'll also see this top edge here as flat across here, all the way though out here, I think. Clear out to this extent. This edge will look like that, and this edge will look like that. Clear out. Those two edges, they're foreshortened here actually, so they're not quite 20 across. Then from there down, I'll finish off the gusset, I guess, is what I'm looking at doing. So I'm going to offset this center line that I have. The gusset is 16 millimeters across, and I'm working it out from center. So I'm just going to offset that by 8 millimeter and then trim it to fit. So I think I'll offset by 8 millimeters here. something like that. And I'll push those to visible lines, something like that. And then I'll just do some trimming here once I turn off this construction layer for a second. Well, that wasn't exactly how I wanted that. Come back one here. Trim. Do you want this one trimmed? It stops right there. I shouldn't see the bend across that. And then I think it's just how I had that selected that the way I trimmed it, it kind of trimmed it like that. Okay, so that should be top down looking at my gusset now. Now I've just got to kind of work on what's going on here. I think I'm going to trim these out. I don't think I'm going to show the radius extents of this. I don't think I totally have that exactly right yet. No, I'll work this out though. That's my bend line, right? Turn back on my grid here. Right up to there. Yeah. So now you get all these features that are kind of strange to put in, right? Because they're not circles, they're kind of ellipses here. So let's just see what we can let's see what we can figure out here. So I think I'm going to use projection to do this, but I think I'm going to use projection on another. I think I'll just turn off these projections um and yeah, I think so. And start a new projection layer just to start to get the distorted features dialed in here. So let's see what I do. Feel like I'm going to start with the outer radiuses here and then worry about the holes last, but I'm kind of worrying about the big radius ears features. I might consider those kind of like the ears that stick out and then how they go back in. So I'm going to worry about this kind of ear and I think I'm going to project up from the front view to do that. And then I've also got a radius of 10. So I've got the big ear, and then when it radiuses back into this 80 millimeter wide area here, I've got a radius of 10 here. And so I'm gonna definitely start a new construction layer. I might push this one to center layer. I think I'm gonna need this. I'm gonna push this to center. Um, this is gonna become center as well, but maybe I'll draw over that one. I'm not gonna worry about that one yet. I'll just focus on this one. So what I'm gonna do is make a construction layer copy. So I can turn off this one and draw on construction layer 2. So I'm just going to project between these two views some of the features that are going on here. And I might need to draw one more construction layer feature. So I want to know from here down 50 millimeters, because that's kind of that is the diameter of the ear. If I was looking at the ear, which I am looking at it kind of straight on perpendicular to it. So I see it as a line. It's 50 millimeters, not foreshortened in that. That's actually the true length of it. And then from there, this feature. So I'm going to draw this in as kind of the extent of the feature of that ear. That's that whole shape there. This whole rectangular shape is radiused in my view now, and this is where it turns back to and where it turns back, it's a 10 millimeter radius, right? So let me just focus on this for a minute. It turns that back, and then as it comes into this one, there's a 10 radius here, a radius of 10. So at that point, I'm going to draw another 10 down, and I'm going to kind of show the extents of that radius as well. So I think I'm going to offset this by 10, this one here. So that's kind of this is also a radius feature that's kind of like radiusing back to the 80 millimeters. So now I'm just trying to make sense out of what I'm seeing here. They're radius features. But those are kind of their true lengths. I would see that radius at its true length right here, that it would measure 10 right here. And so I'm not going to make these be visible lines. Sometimes we have shown that's the extents of that radius that I see where the surfaces kind of blend together. I think I'm just going to use them for projection material and not use them for actual visible lines. This one would be though. So this one, if I think about this, once that turns and goes away from me, I would see the surface as it goes away as a visible line. So there is an argument that as I'm thinking about this, that this one would be visible. So let me like match these properties. Oh, if I can, if I actually finish my selection before I exit. Oh, it seems to be, that's weird that it won't, oh, I don't know. That's weird. I got it though. That one I would see where that, so yeah. Okay. Now I'm going to project these up and across my other view there. So I would have, this is where the radius would stop there somewhere up this way. And I would also have this one. I'm going to drag it up. And I'm going to drag up the center line to maybe base this off of here. So I'm going to drag up the center line as a projection line here. I'm just kind of projecting them to the overall across everything there. And so what you really need to know to do this is you need to know kind of the center point of a radius. So really what I'm trying to identify to draw this, like the geometry of this, and however you decide to do it is fine, as long as we're going to get there. But I'm gonna base this. This is not going to look like a circle in my top view. It's going to look like an ellipse. What an ellipse needs generally is what we call major and minor axes. And so, like an oval has a longer and a shorter width. So it might have a major that's like longer in one direction, and the minor is shorter. If we were to draw center lines through an oval, which is essentially what we're doing, center lines through a circle, they're all the same, right? When I'm looking flat on a circle, the center lines, and when I divide it into quadrants, same length. Well, not so when you look at a distorted circle. It's going to look like an ellipse. And our ellipse command likes to know, you can draw it several different ways, but one way to lock it in is if I can lock in the center and I know kind of the extents of the major and the minor axis is what I'm going to try to block in up top. So I'm just focusing on trying to get what this looks like up top. And it's I would say it's like it's 50 millimeter this way, and then this way it's going to be I kind of want to know where my intersection point would be. So let me come back here where the center of that would be. Center is center. Everything's concentric here, the hole and the ear. And so I've projected that center across this way. What I want to know is the crisscross center in kind of where the X on the X axis, like where that center line crosses this center line. So I'm probably given that information. It's really going to be 25, the radius is 25. So if I just come over 25 from here and put in a cross, I'll have like a center point to base an ellipse off of. So I'll show you. So really, it's because this ear radius is 25. I'll draw this over as 25 since I'm on a construction layer. 25 right there, and then it's going to cross over, and maybe I'll just pull this way beyond. And then I think I will extend this through my part as well. So that's an arbitrary length line from left to right, but it is specifically 25 millimeter over. So this particular point is pretty important to me. It's where the ear is kind of based off of that concentric part, and that's my center line being projected up. That's one of it. And I'm thinking about it on this kind of surface that I'm looking at, this sloped surface. And so now that I have this, I go to this ellipse command, and maybe I'll do this as visible line work. So my ellipse command is right here on my draw palette. I don't even think we've used this yet, have we? I can't remember. Maybe not. Everything else I've used. This might be the last thing. I know we don't use arcs a lot, and you could piece this together with arcs, but you have this cool ellipse command that will either draw like a center-driven ellipse or an axis and an end, or an elliptical arc. So I think let me just choose the first one, center. And I'll just follow the command. Specify the center of ellipse. So it was critical for me to know where the center of that ellipse is. Right here is what I've got. And then it says specify the endpoint of axis. And it doesn't matter which one. There is one called a major and a minor. I think of the major as the longer one and a minor as the shorter one. But so you might need to know one more projection line. Sorry, I'm going to do this. I've really already got it. It's going to be what else would be on this line that I need to know is this extent here. Even though I already have it, it's right there, but I'm just going to project this over real quick. Sorry, just to keep my thought process together. So really what I have that this is this ellipse is going to be in this view. I see that it's 25 or sorry, 50 millimeters all the way across. Well, when I project that up, it doesn't really measure that. It's like a foreshortened when I'm looking at it in the top view. And so this distance becomes this far. It's only 25 across here. It measures 50 here, but it just the distorted image of this ends up being, well, it's half. It's not always half. It just happens to be the slope that we're at here at 30 or 120 degrees over, and 50 millimeters ends up producing this projection that is 25 millimeters across. So that's kind of the length from center out here, how long the ellipse would be in this way. And that's what I would consider its minor axis here. The other axis is going to be what looking down on this, I'm going to actually see its true length here, though. So I'll see this as it will measure 50 millimeter across this way and only 25 millimeter this way. So I just need to have some points to pull that to. And so I might project a little bit more work here, some kind of a boundary to, I'm just projecting this across, arbitrary. So this is going to be the major kind of radius of this ellipse. That's 25 and then 50. And then this is going to be the minor radius of the ellipse here, which is going to be half of whatever this is. Half of 25 is 12 and a half. So this ellipse, now when I'm under the ellipse command, I kind of have some points I can just pull to. So I'm going to grab that ellipse by center. This is the center of the ellipse. Then it says specify the endpoint of it. So I'm going to pick one, and then it says specify the other endpoint, which is this one. And so that's kind of what that looks like. That's why I said working off projections the best way to do this, because it kind of already locks in those lengths that you wouldn't know normally. Like I don't have, I could calculate that, sure, but I can let AutoCAD calculate that for me just by projecting the extent of it. Yeah. And that's how you use that. So now I got to trim this a little bit so it actually looks like what it's supposed to look like. It's not big and blocky square here. It actually like comes up and around to this point here. And so, yeah. So let me show you how to I mean, this gets a little complicated. That's why I love these. I love these ones. They get a little bit more like you're drawing 3D. And so now what you want to know to complete this is the front or this is the top surface. This surface is slanted and foreshortened to me, but it's actually what I can see. Well, now I have to kind of consider what the thickness of that ear, and it's like 20 millimeter thick, but it doesn't measure 20 millimeters here because it's foreshortened kind of up here. But I need to know like what the extent of this is from like this surface that's towards me to the surface that's kind of buried in my top view. I can't see it, but so what I'm going to do is I'm going to project this center line up to here, because this is all based off of this center line. Now I'm going to project this center line up, and I'm going to be able to copy this over to that center line where, and because, yeah, that's all I have to do is actually make one more projection from where the center line exits the thickness of the material here, right? This is what I need to know where it exits. Maybe I'll pull this one through here up to there. Because that's essentially, this is the surface that's towards me in my view, kind of, and then I need to know where it exits kind of through there. And I can think of the hole exiting through it, or just the physical feature of it. So this is that's where that one projects up, and I made the cross across the same center line. They will be in alignment across this x-axis in the top view. So all I have to do is like make a copy here, copy this. I could trim it before I do this too. It's not that you have to copy the whole thing like I'm doing, but it does need trimmed. It doesn't look like this. It's not the whole. Remember, it's actually the outer edge. But I'm going to select it by its center point, and then I'm going to drag it and put it right here. And now I've got to like turn this off and start trimming. So I think I'm going to go to this visible object here and maybe turn off this one for a minute. Try to make sense out of what I've just done here. So this one I'm going to extend over here. I'm going to trim some of this. This plate comes up around. I won't see this edge like this. I won't even see this edge here. So then I start like squinting my eyes and taking a pretty hard look at this. This isn't the whole feature, so I'm not going to see both. And I should probably trim this to fit like this. And then that's how the transition of that plate would look. Looks a little bumpy to me right there. Let me think about that a little bit. And I won't see this side of it. I won't see any of this actually poking through, so it becomes pretty severely trimmed here. Let me get in here and trim this. And then that surface is going to trim out like that. I think this might look like it comes a little longer up. I just don't like this little bump that I'm seeing right here and how I trimmed that where those two met. I might need to take that up a little bit further until the quadrant of it. And it's going to look like it smoother until it hits that quadrant, even if it extends beyond there. I think that's what I might be missing here a little bit is that in order for that transition to truly take place, I shouldn't have trimmed this one out. I might just delete that one real quick and use my one that I've actually trimmed now. I might make a copy of this one. I want to take a look at this back here on this. Am I pulling that out of alignment? It almost looks like that thing has been pulled out of alignment here. Let me look. Distance here. 704. No, I think we're doing right. I think I just messed up. Well, I don't know. Like, let me think here. I feel like my projections that line is slightly out of. I've pulled it off center just a little bit because what I wanted is this center line here, and I think I may have pulled it slightly off. That looks a little bit straighter to me. So I think that's what was causing my issue with my alignment. So if I'm going to copy this now. Ah, that looks so much better. It was just my projection line was slightly off here. So, oh, I don't want to move that one or delete it. I just wanted to make a copy. Sorry, copy from here to here. Oh, that looks better to me. Yes, trim. And then this one, I mean, I only need a little bit of it because it's yes, like that. This is going to be trimmed out and it's going to be straight from this quadrant to this corner, except for I got to put in a little bit of a, I've got to do another ellipse here to finish this. So I think I'm going to do that and then I might join these and mirror them across. I'm just kind of working this side. I'm going to work the whole. I might even work a lot more geometry and then and then I'm going to project most of that across over here. So I'm going to just keep working this side and think of doing a mirror once I dial it in here. So when I look at that now, if I turn this off, this should look a lot better. Oh, that looks like it makes a nice smooth transition. Yes. Okay. It's still not done here. It curves back too far. And once it actually hits the quadrant, I'm going to see it as a straight transition until it goes into the other radius. They're going to fall in together pretty good, but I think I'll finish it off straight and then I'll trim it with the other radius. You don't have to do this little step, but I think it's just how my mind works a little bit as I kind of keep it up. Oh, well, that's why we're here. Take the long way home. Do, 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 do. That's a song. Hey, you took the long way, but you got there, right? As long as you didn't get like murdered on the street or fall into the hey, it's coming up. We're coming up close to the last phase of Stranger Things, right? I'm a pretty big Stranger Things fan. I'm mostly a season one Stranger Things fan. After that, they had to get kind of crazy, but I still watch it. But the Upside Down, I love the idea. I love the first season. It's got just the right amount of like I don't know. It's just perfect. A little bit. They try to define things too much, and I like the mystery of the whole freaking thing. And I wish, and they could have just left it with one season. Oh yeah, it's like the kid on the way home with the bike. I love the whole concept, right? Like the kid that. Anyway, you don't want this in my recording, my Stranger Things rant, but you're gonna get it. I love it. Yeah. Will goes missing. Oh, I love that. And then the first few shots of the Demogorgon. Oh, I love it. It's perfect. And the mysterious whatever lab. Perfect. Quintessential 80s. Yeah. Yeah, crazy girl with crazy abilities. Love it. Yes. All right. But I like all the Russian stuff too. It's good. That's also quintessential 80s and pretty current. Let's see here. So now I'm worried about this one here. And I think what I'm gonna do is I'm gonna put in the center line here and build this out. Well, you'll know with an ellipse, generally you're gonna like to build it off center or build it off the extents of the axes, the major and minor axes of an ellipse. You have that information here. You just got to project it up. So what I'm maybe lacking is this was a 10 radius. So I'm gonna do one quick little a 5 offset here for this little center line. That's actually the center line of my radius. I could put that. I'm not going to change that to a center line because I don't want it to. It's not going to be a center line that's going to end up in my print like that one's going to. So I'm just going to leave it. I just know that it's a center line, and what I'm looking to establish is the crisscross center line of where it's X and Y center is up top. So let me focus on that first and finish this. Construction 2 is going to center line up here. So I want to know where this one comes across, and sure, I can take it like I've been doing all the way over. Really, I'm just focusing on where it is right here. So this is definitely this. And then I have to know, is it on the same axis of this? Well, be careful here. I don't know for sure. This is probably not. Let me see what this measures. So maybe it is. Maybe it is. Let's see here. The distance here. I just want to know what this is. That's 5. That should be correct because no, is it? I don't know. What am I thinking? I'm thinking I need to know where I know that this is the center line from the front view up. Now I just need to know where the center line is from top down in its true length would be. Yeah, if this is a radius of 10, it's going to be 10 over from maybe this edge here, 10 over. So I can't assume that these necessarily the center line for this ellipse here is the center line for this little transition here. So let me just double check that and be a little careful up here. That only measured 5, and I think I need to come over 10 to actually know where its true center line is, right? So I feel like I'll do just like I'm just going to use a layer that we're not going to use much, a chain layer here. And I just want to do another line here because technically on this center line coming over from here, it should be like 10 is maybe the center line of this ellipse here, right here. So it really should be where this crosses. So if I put this line in here, it's kind of this way. And I'm going to do this one kind of short because it's just, and I know I'm on a weird layer. Probably could use my section layer. It's a continuous line instead of this, but all I'm looking to do is establish this is the center point for this other fillet and how it transitions back into the 80 millimeter wide here. So this, I'm going to use another ellipse here. And I think I've dialed in what I need. It's a 10 radius. And this is a 10 radius, but it's severely foreshortened in this view, right? This is what 10 radius looks like severely foreshortened in my top view. So that's the minor and the major axis kind of here of this. So I'm going to choose my center driven ellipse. Here's the center. And I'll say, well, it's like this. Sorry, I'm on the wrong layer. Let me go to visible and pull up that same center type ellipse. Here's the center of the ellipse. It goes this way, and then it goes this way. So it's a really quite squishy foreshortened, but this is what the transition would look like as it turns back into to the 80 millimeter here.
I had the same problem where they didn't quite touch, so I had to like move it over to where they didn't touch, extend the line that I had it on, and then make it again.
Yeah, let's see. It's going to touch, but it's going to be, yeah. It's going to be right here. It's just that you need to draw the line where they touch, right? Yeah, it's right here that needs to come together with a visible line, right? And then trim out what doesn't. Yeah, I see what you mean. Well, we can just like I have a line drawn there. I can just extend it through to this here, to this quadrant to this. Then I can decide to trim it how it looks. Correct. So let me turn off some of my construction work here. Maybe I'll turn this off and turn this off and take a look. Yeah, it definitely takes a little bit, huh? And then I'm going to trim this, and trim this. It doesn't seem quite right to me though, actually. But that should be right. It's 10 radius over. Yeah, if I would have moved that over more, let me think if I did that right or not. It's a 10 radius. I do agree. It's a 10 radius, but it is only five. Let me think. Yeah. So my mistake that I've made is that I went over 10 from this edge over. That's not necessarily true. So what it means, okay, so I should have misinterpreted this or I misinterpreted this a little bit that really this radius is going to be based off of only 5 millimeter over where the center line is. And even though it is a 10 radius or a 10 radius, it's only 5 millimeters over from the edge. That's a little bit misleading here. Can be because it's only 90. That's only 10 more than the overall 80 here. So that means it's only 5 and 5 over. Yeah, let me try that. I think that's all I need to do is fix this fix my ellipse. Yeah, they should touch. That should have been an indicator. I'm like, nah, that's not quite. I'm not quite pulling the right. And then they are based off this same center line this way. So this is my mistake here. Coming a full out 10. Really that radius is actually living out here in space somewhere, the way it fits. It is a radius of 10, but it's not. Yeah, that's tricky. So I'm gonna delete this one and redraw a new one. Maybe I'll delete that line there too for a minute, and then I'll come back and say, really what I've got is a center-driven ellipse from this center to this and to this. Yeah, maybe this looks, and then these definitely for sure. This has still got a 10 radius. This is 10 across here. So yeah, I think that's right. And this should measure 10 across it on the top. I say that like scarily. 10 there. Okay, so that makes sense. 10, that's a 10 diameter though. Hmm. Hmm. Well, let's move on. I could stop and think about that a little bit more, but let's it's probably the same as I have here though, from what you were saying. Yeah, that seems correct, huh? You're right. Yeah. I'm gonna leave those on the center line here. Yeah, that's good. I need to put the hole in though now too. So I'm gonna put the hole in. So I might join this. I'm going to it's not too much to select actually. I don't have to join this, but I could join some of this. I'm just kind of like I'm gonna mirror all that across to the other side and do some trimming. But I think I'll do the hole along with it. So let me do the hole. And maybe even so I'm gonna turn back on this layer here. I've got my hole center projected over, and I probably have its extent. So the hole is what 25 diameter? Yeah, 25 diameter hole. So I can go right here, 12 and a half over this way. So I could put on, maybe I'll still use I'm kind of sneakily using my chain layer as kind of a different color. But I could make a construction layer with a different color would be helpful too. But in fact, maybe I should do that. Just let's do this right instead of doing that. I'm kind of hacking my way through a little bit. I definitely want one that's not going to print or plot or show up unexpectedly. And so I'm going to make a third construction layer. And then while I turn that on, that's the only line I had on it. I'm just going to push it to my third construction layer. Then I know I won't be surprised if something plots I don't want. Okay, so here, this is a 12 and a half diameter. So 12, sorry, 12 and a half radius. So that's 1/2 of yeah. And I haven't projected up the extents of that, so I think I will. I'll project these up. This is the extents of the hole that will come across. No reason to pull them this far, but I am. And then I need the other extent of this hole right here. I already have that one up there, so. No, I don't. It's this one, sorry. So this is one of the yeah. So this I'm ready to draw an ellipse in for the hole as well. So let's do that. the same ellipse command here. Yes. Goes out this way and it goes this way. That one's pretty easy to pop in there. Diameter of the hole, major axis of the ellipse, minor axis of the ellipse. And then it exits through the plate as well. So I have to consider it that it will go through here and through the backside where it exits. And so I'm going to make a copy of that, make sure it's going to be on the same concentric this way. I just need to make sure that I've projected the center line up, which I have already. So at this point right here, I need to make a copy of this thing and go ahead and place it back here where it will exit, right? And eventually what I see is I'm going to have a piece that I don't see at all. Like that's going to be the hidden feature. It'll be buried in material. Unless I have X-ray vision, I won't see this. So I'm going to move it to a hidden layer. And then what I would see in there, if I'm thinking of this, is I would see the sides of the hole go through as a line here like this. They would be hidden. What I really like is when we do this and part of that will show up. Like if the thickness was thinner, you would start to see some of this show up in here, and that would change it from being some visible and some hidden. And for whatever reason, I love that. I don't know why, but this also is cool. So that shows where it exits the thickness there. So I'm going to copy all that stuff up and over to the other side or mirror it across. So I might just turn off these layers that I've used here and decide what stuff I'm going to copy. But that should be it, right? Yeah, I think so. I mean, I could put some center lines through there and do that, but maybe I'll come back and do that last. And yeah, I think that's the correct profile that I would look. So let's make a mirror of that. And all this stuff is coming with me. Yeah, that's all I need. I'm going to mirror it across the center line somewhere if I have a center line. How about there? Beautiful. Now we'll come back here and trim the stuff that needs to be trimmed. Seems pretty good. Cool. That's definitely the lesson of the day. Ellipses, how to draw them. Establish a major and minor axis based off your projection. Yeah, I like it. That's the bend coming up. This is the surface that's foreshortened to me. So I just need some center lines to finish my views. And I need to continue this one through. This is a through hole. Does it say that on there? I do think I said on mine that this is a through hole through all. So when I ended up marking the 35 on my print, I think I ended up marking through all. And so you wouldn't know that. This isn't really clear, but so this what I'm saying is this does go through both. And it's just because I made it so it did. But if you didn't do that, you would, I guess, it wouldn't necessarily be wrong because it's not clear if it goes all the way through or not. But that's going to go through all. That just goes through there. This little center line needs extended by at least 10. Is that right? 10 millimeter, right? 6 millimeter. Good call. Not 10. 10 would be how far I would space the dimension. Yeah, quarter inch is essentially the equivalent. Yeah, so that's like that. And then we'll do some more center line work, I guess. I do have a little bit more hidden line work. So I also need to know where this back edge of this turns up. I have the front edge here as a visible line, but the back edge I would see as a hidden line across too. So I'm going to do one more projection, and maybe I'll just do it on this. I'm about done with projection, so I'll use this layer. And but this back edge I would need to project up, and it would become a hidden line across. That's the way I see it. Yep. We'll use that one. Cannot. You have to use center lines. Yep, yep. So I could do a center line and use these two hidden lines for my center line like this. That's probably the way I would start it. and I could do one and then copy and paste it over. But yeah, I still use my center line command and use maybe something like this. And then I'm going to pull this through to here, probably initially through here, and I'll do my extension, that's 6. Those could extend definitely to a dimension potentially. So where I'm this close to going through both sides, I feel like I'll probably extend that a little bit further. I don't know, like 10. I think just because I have some lineup going on there, I'm choosing to extend my backspace. Let's see here. I'm choosing to extend those through the visible lines there like that. So I know that is breaking the rule a little bit. So I'm actually going here and then here. And then I'm adding like 10 on here just so I not 40, let's go 10. Yeah. Not just showing it through. And then I'm probably going to pull some dimensions through here too though. So I'll adjust them at the end when I decide what they need to be. And then I just need to add this center line between this whole. And then it's time to work on the auxiliary view here. So once I finish the auxiliary view, that's just, I'm ready to dimension for the most part. I think I'm showing, can't see that I'm missing anything necessarily. Auxiliary view, let's do it. I'll probably build it on another, even an additional construction layer to start it on its own. Some unique name. Oh, I think that one will copy my last one and it'll be, I think I'll go back to, it doesn't matter what color actually, but I'm just going back to the original construction color. This is kind of, some of these we've done have been pretty friendly for auxiliary views. This is another one that is kind of friendly, right? Because this angle is the 120. So I have a polar alignment here that'll work pretty well as long as I have it toggled in. It'll be my 30, 60s, 90s, 120s. So to build this projection plane, I feel like is if they're odd, if you don't have something to snap to, I think it's a little bit harder to draw them. This one I feel like is kind to us here because I can actually build a projection plane on an actual snap like this, 30 degrees here. And I'll just build this thing out here a ways, enter, I don't know how far a ways it looks like. Probably planning on taking that view out a ways. Knowing that I will be dimensioning here. If I place this here, yeah, I mean, I'm going to be dimensioning in here. So this thing's going to have to come out and probably catch its own viewport. So I just might get it away a ways here. I mean, if I put it out here enough, I might be able to get everything in one viewport. I don't know. So, I mean, I'm not going to be too crazy about it, but I'm going to do this partial auxiliary view. So I think I'm going to project, I think I'm going to offset this piece over across my plane there. Some unknown distance. I can get a quick feel for how far I might offset it. Oh, I'm probably going to come out here 200 300 millimeters away maybe and build it. Sure, I'll do that. Doesn't really matter. So I might offset this thing by 300 millimeters. And it's this thing this way like that. I could use that as a center line of my piece, or I could use it, I'm probably going to use it as my center line of my actual, uh, yeah, I think I will use it as a center line. And so I'm going to look at the overall width of this right here. Like if I built this correctly, I could project over and do all that. I'm just going to actually build it like we have our other auxiliary views. Like I'm just going to kind of piece it together here with the overall width and which was 140, right? So I feel like I can offset this thing by what, 60? No, 70? 70 sounds right. 70 sounds right. And then I can definitely project other stuff from there though. Like the center of this is right here, right? So it would project across. Make sure I'm on those snaps. That's the center line. They're spaced 90 apart from here, so I feel like I can offset this 45 again. Like might do another offset of 45 and say this and this. There's the center of the circles and the radiuses, so I think I can start to piece this together with visible line work. That I would have a circle here. Yeah, I did 45. That's because the spacing on my print here is 90. They're 90 between the two. So, and I'm working off center, so 45 and 45. That allowed me to get this. I projected this one up from my front view, and then so I had that cross intersection to, and then this. So I've already put my radiuses in. I just need the diameter 25, or I think of 12 and a half, like that. Overall width of this is 80, right? So this is 80 right here before it makes all that transition stuff. 80. I don't have that. I have 90 here, so I could offset again. Offset 40 maybe. Maybe I'll do that. I'll do another offset of 40. And then I'll do this one. That's the actual width of part right here. So if I'm drawing this, it's actually only 80 right here. Yeah. And then it comes up some unknown distance here. Maybe I'll put in kind of only drawn this side, and I think I'll finish off here, and then I'll project these over. I'll trim them and project them. I mean, this is going to be from, I'm going to have a line across the top from quadrant of that to quadrant there, kind of piecing this together. And this would be kind of a straight section. I need to tie it into the radius here, right? Which I could use as a fillet. I could do this as a fillet if I draw on these two lines, right? I could just say this one comes to here. If I trim this, then where these fillet, maybe it'll fill. If it won't let you fill, it's just that the lines aren't long enough to do it. So I might have to draw it in, but if it will let me do it, it'd be a fillet of a 10 radius, right? With a radius of 10. And it won't let me do it because of the distance I have, which is what distance? Right here. It's only 5 millimeter. That's the difference of how wide the 80 millimeter plate is to the spacing, and it's 90 millimeters. It's 5 on each side. That's why I offset 45 and then 40. And then I might need to draw this in. Maybe I have to be a little more accurate here, or do like a tangent to tangent, maybe. Yeah. That sounds like a great use of a circle, right? Like this tangent to this tangent with a radius of 10. Doesn't work great, but maybe it does. What's that? No, it doesn't have enough distance to cut it. Like if it's a 10 radius in this area, it just doesn't have a distance to cut it. And this shows the same thing. Like it's almost like this part is like works for you.
Worked perfect.
Maybe I didn't pick the right thing to go tangent to here. Because I should be tangent radius, right? Tangent this to tangent this with a radius of 10. I actually pop it way out here like this.
Minor touches.
What the heck?
It might be because you're mentioning not that that line instead of the actual circle.
You can't tangent to it.
Yeah.
It actually does work that way. Yeah, it shows that this is the transition point, huh? Just barely. So if I trim this out, yeah, that's true. I did have to pick the circle as the tangent. There is no straight section. It's like the radius comes in and then leaves, and then yep. Yeah, that's good. I gotta trim all this up to make it appear correct. So maybe trim. That hole will stay. I'll leave on my grid a little bit. It'll make some extra trim, but this will trim. That'll trim. This should trim, and this trim out, right? I'll zoom in here a little bit. Yeah, that looks correct. Still trim this out here. That looks like the ear on half of it. Yeah, I think so. I'm going to mirror that across. The center line. I just got to finish a little bit of visible line work here. And then I should see the gusset. So I'm going to not only, we would forego hidden line work if it was if it cluttered my view. It's not that you can't include hidden line work, especially if it's helpful. Here I don't have any hidden line work to show, but I do have visible line work, and I would show that. So I'm going to show the gusset that I'm looking down on here. So my view is definitely looking down. I'm in orthographic alignment, but I'm going to do an offset of 8 again because the gusset's 16. I'll just use my center line for my gusset here, and then I'll change those properties so they look like a gusset here. And then I'll toggle off my construction layer here. Yeah, that looks correct, huh? The other thing you'll notice when you do circles, I think.
So, with the visible lines go all the way down the part though, because they don't exit all the way down the part.
Right here.
Yeah, see, they don't go to the bottom of the vertex. They go.
Yeah, what I'm doing is I'm doing a partial auxiliary view. And so this is where I end so I chop off my view. It'd be funny if I should show that as like chop material, maybe would be helpful to the viewer if I did like maybe like a jigsaw looking edge here. So it would be like that's where I truncated my part. I'm just gonna leave that long. But yeah, you're right. Like if I was gonna show a full auxiliary view, I would have like a lot of like I would have to project this stuff across and get another ellipse and some foreshortened looks here. And maybe it doesn't. So this is, I feel like it's pretty common to do partial auxiliaries just to expose what I'm truly trying to dimension. And because this would be undimensionable material here, and I'm going to be able to dimension that stuff here and here. And so it doesn't add, yeah. But you could continue it. We did a full auxiliary on the V block that had both going on, but I've truncated mine. Yeah. And that maybe is confusing unless I really showed that, but I think the viewer, yeah, gets it. Not really. It can be confusing, but
Imaginary.
definitely, yeah, definitely partial auxiliary is what I've done there. And we your book, you probably read about that quite a bit, but center, I don't think center like the center marks don't work well here because I think or I think they'll put them in orthographic alignment here, and I'll actually want to put my center mark in the alignment of the part and not like this. So I'm not gonna drop these center marks on here in the X and Y. I want to actually have them here. I could do that and then rotate them though, right? You could actually drop this. That's probably a command you don't use a lot, so maybe I'll show that. We could drop that center line on here, but I probably would do the full outer arc to show the concentric nature of both, right? If I drop that center line, it might be better. And then if I do take care of the extensions before I forget always. And then I can rotate. So you have that as an option here, rotate. I don't know if you use it much. I use it, but maybe I haven't used it much on drawing. So I'm going to rotate this thing, and I think it'll want to know by what axis. And then it might want to know that I can snap. Since we're in like 30, 60, 90s, I do have a snap here that could go like that. So that's a legit way to. Center mark, I use this as my driver of the length, so it's the overall radius. Yeah, I chose that as center mark, and I picked the radius, and then it extended it. Yeah, so both are, and I'm going to pull those together too. So I'm going to make a copy of this, copy that, Roger that, copy that. Here we go, right there. Well, when I have this going on though, I do love that I will probably pull these together at center somewhere, maybe there. Yeah. I just pull them together like that. They overlap a bit. That's okay. I might find that I think I found that I probably extended this one. I don't know what my little cheat sheet looks like, but I'm about at the dimensioning phase. I'll probably end this. So I'm here right now. You can see that probably when I went to dimension, I pulled. Yeah, I'll take another look at mine. I have that line right. I have those lines. I have that. I have to zoom in here to see. I think I have the hidden line. Oh yeah, I do. It's that hidden line right there. But I think I'm going to pull these. I think I end up pulling this through because I end up dimensioning from it. So not that I want to give away the dimensioning because that's going to be the hitch to the assignment now. Is use your dimensioning skills here. Just break that. That's, you know. But I do feel like I never put in a center line dimension this way, so I think I will, or a center line. Um, this way through the part here. I ended up adding one through here. And then I think I ended up coming to here and I even extended this maybe 6 this way just to show the concentric nature through that. And I don't do that on the back side. That would, you know, while it could be useful and I might in some cases, I definitely am just doing it on the front side surface. I am showing this one through both. And so why I don't show both? Well, it just maybe adds a little bit of confusion and maybe this is just a little clearer that the visible line is what my center line and the one through the other way helps show that the alignment of that through. But yeah, I would say I don't always add center lines to hidden line. Well, I can't say that. We do that a lot here. That's what's going on here. So technically it wouldn't be wrong if you, to me, if you copied these over. Um, but I don't think I did. I think I just left it like this. And then this one ends up, I think I need to catch a dimension with it. So I extend it the other way. And it might just be a location dimension for something. So if I thought of like even before I go to dimension it, so I'm going to end this video where I just talk about maybe the datum and the controls of this thing. Like what are the best surfaces to base? Well, definitely the base here. I feel like my front view datum is probably going to be this flat surface that's sitting down. And I'm probably going to pull some dimensions, you know, linearly up from this. Maybe I'm going to try not to chain them, but I'm going to try to like probably base quite a few of the dimensions in the height category from here, and then I might need to decide if so. I feel like front view definitely my base is gonna be the control on some, and then if I think of well, what about left to right? Well, if you think about this part and in this orientation, this edge is not a great edge to base dimensions off left to right, nor is this edge because of the radiusness of it. It's not that I couldn't. You know, that would be like pulling dimensions either from here to wherever they are this way, or it's pulling from this edge over. But I would say I would probably kind of avoid those because they're like, well, they're edges and they're really small surfaces in some ways, right? The truly tangent point of this, the point of tangency to the real like y-axis line here would be a very small surface, right? So to pull dimensions from left to right from that, not some from right to left from that is probably not the best. And pulling from here from left to right off this little edge, this isn't a surface, this is an edge. So the edge, you know, the surface is here and it's not aligned to X and Y. So maybe it's not a great thing to pull dimensions from here either. They'd be an aligned dimension, which in ASME we'll try to avoid. It's not that we can't put them in, but maybe I'm going to try to do point to point X and Y, right, to locate stuff, to locate edges and to locate things. I do X and Y type coordinates, point to point. So so to me, if I analyze this part, I don't love pulling from the extents of the part left to right. I just don't like it. They're just kind of there are these strange surfaces and their edges. So maybe I would think of this as being a great control. Like maybe the concentric nature of all the thing that's going on here is a great place to start basing dimensions from. So if I establish this is a better control on the, you know, on this vertical line, center line, I could definitely base dimensions from the left and to the right off of it. It's a great control. And I could do the same here. You know, I don't think I'd want a dimension from here, from the back or the front. The best surfaces to do that would be these surfaces where they're flat. And this outer surface to here is probably not a great dimension to pull. But what about if I extend this out through here? And I think of control now being like the X and Y of the concentric nature of these and basing other part locations from that, and the bottom surface maybe being a control. So that's my advice in how I would maybe consider dimensioning is maybe avoid the extents of these and pulling dimensions from these extents that are all radius features or edge features. And think about pulling from the center lines, which I can think of as center planes, or I can even think of it as a center axis here as well. So those are strong controls. Nice flat surfaces and nice true axes and centerline planes are better controls than some weird outside surface that's slightly contoured or as an edge. Not that it can't be, It's just that maybe if I have a better selection, I would choose it until I absolutely can't. And then I establish an edge maybe or a real radius tangent point as one. It's not that I can't, but anyway, call good.
That.
Yeah.
Where it meets the cylinder shafting, I think there's
Yeah.
something, hidden line, you put the projection lines down from that, you had cursor over down to that.
And then I would see that there would be I would oh yeah, this would be slightly further out, right? Because I'm looking at it as the center point. So I see what you're saying. So if I like, yeah, like let me fix that up. I like that. Turn this on for a minute. Maybe I'll project it from right here. But what you're telling me, and I understand, is that this, what I've got shown is this point down, right? Like if I project this down, this is where I've actually got that. And that's not what I would see. I would see this. I love that. That's that small detail. That one is the one that would actually be the visible line right here, right? I would still see this though too, huh? Because I would see not necessarily because we don't know the relationship, but yeah, we wouldn't see it. We would only see, I feel like this one I could almost move in. Um,
You just have to take that angle line down.
this one here
Lengthen that.
to here is what that would look. Is that right?
No.
No, that's not right either.
You want to just keep it at the exact same angle and just lengthen it, yeah,
To here.
but kind of mess it up, so. I think it came off that point.
I think it did. Yeah, it did. And I don't know where my moved, I don't know where my moved line went. I thought I moved it, but then
It might have gone under the line.
I think it did, huh? When I moved that, this one is over, this one has top favoring now. Yeah, I see. So that's going to be almost all this would look shorter, huh? Potentially. No.
Uh, like, no.
That one's got to maintain that diameter, huh?
So,
That maintains the diameter. Oh, yeah.
I would just draw another visible line under construction. Yeah,
Yeah, that's what I'm seeing. This one comes down for sure. This is the visible line that I see
just draw a line connecting your angled line
to that.
to that, or whatever, so you can keep that angle.
And extend works good for that too. If I hit extend, maybe this one like this,
And now you can just hit that, yeah,
this one out.
that.
This is more accurate. Yeah, that's weird going on there, huh? I probably don't have that in my drawing on my other one. But that is that one needs trim too.
Yeah,
I see it. I see it. Yeah, and technically that surface is probably having to be contoured like this, huh? Like that gusset actually has to have this like almost like either milled out or something has to put this contour in that shape of that part in order for it to match that. Yeah, that's a good catch. It's kind of it's a little bit weird going on there, huh? Yeah, it's a little bit more complicated. If I'm truly keeping this surface flat, yeah, this is correct, huh? But because I need this overall diameter still. Yeah, good. That's a good catch. I don't think I've caught it before. I don't think I don't think my drawing currently, if I pull that up, I don't think it has that detail in there. That's good. That's a good catch. I need to save this thing. Considering I did all this work, trusting that the third of the internet one's not going to just zap out on me. Super dangerous. Let me do a save as here. So I've got a new one of these going on, but that's it. We just got to dimension it. And I definitely think about where to pull your dimensions from and to, and watch those edges as maybe not the best, but you do have some good places to dimension too. So this is our spindle base, at least my ortho in class. Yeah. And maybe the last thing I'll show for those that ever watch the videos that on the because I still am recording right now on the tail end of my video, I will put at least a reference for you to double check here, right? Like,
It's quiet.
right here. This is probably the way I kind of ended up dimensioning mine. So at the end of this video, if you want to have a reference to maybe double check yourself, definitely challenge yourself to see. Not that mine is necessarily 100% right, but I did think through this one the other day when I dimensioned it, and so and then I haven't really talked through on if you have multiple viewports, you can let them overlap like this as long as you like this works for you. It ends up being a clear view on my PDF, but yeah, just it, it, I guess I would say the other thing I would wrap up with is if you're in here, I'll go to my one that I'm drawing. If, if your view is in, maybe you're dimensioning this, but you're hitting dimensions on this. Yes, you can make a copy of this, slide it up, and then you can dimension it really clean and in a viewport where it's not hitting other stuff. Sometimes every once in a while, I'll even like I make a copy that's clean, but then maybe some of this is still in this viewport that I'm wanting to do. And so sometimes I'll move these to like some layer. Like I'll make another. Here's what I do. I mean, this is you can do this a lot of different ways. But if you have a part of your original orthographic projection that is showing up in a viewport that's annoying you and you can't quite get it to cut out or whatever, I just end up moving those to a layer that's turned off. And when I move those to a layer, I generally make like another visible object layer. I might make a copy of this or I actually might move that to that layer that's turned off. So I sometimes make a visible object layer that I actually turn off and turn off the printing and turn off eventually I turn it off so I can't see it, but I turn off the printing for sure. And then it's just that instead you can move it to a construction layer that you turned off as well. You could just mass select all this stuff and say move it to a construction layer. I just tend to move it to some other like visible. It's like a visible line, and I even mark that it's like I'll call that layer. This is just me. I make a copy of this and then at the end of it I say it's visible object and I say it's clipped in view, or I make a little note at the end of that for my layer that says, oh, this is like I don't delete it so it doesn't show up on my viewport. I just move it to a turned off layer and a non-printing layer. And sometimes it's just a copy of my visible object layer that I say visible object clipped in view. And so then I know, oh, if I turn that on, it probably matches up with all my construction and where I built the thing. So I would still have it as reference material if I needed to like make a modification. Because I feel like these are my master views and I wouldn't want to just like delete them or get rid of them. I mean, all of the construction work is based off those views. So they're pretty important for like once I make a copy to a view here that I'm going to dimension, that's great. But if I ever need work, if I ever have to make a revision or modify that, this is to me is what's holding all the information, and it might be what shows my mistake that I made. And instead of having to redraw everything, I can just come back to this basic, this base where I built everything from, and maybe make an adjustment. Painstakingly, yes, nothing's going to be easy at this point to change, but it is doable, and I can kind of see where I went wrong potentially. It's not great fun. And then you guys have probably already experienced it to try to modify something that went awry. It's hard. So that's it. I'm going to call it.